Today on How It's Made Dream Cars, the Bugatti Veyron, the fastest work of art in the world. The Cité de l'Automobile in Mulhouse, France, was formerly known as the Schlumpf Collection. It houses the largest collection of classic Bugattis in the world. While most car companies were founded by entrepreneurs with a purely technical background, Bugatti's creator, Ettore Bugatti, came from a family of well-known Italian artists. That artistic heritage played a vital role in the design of Bugatti cars, long considered among the most beautiful ever made. But art never got in the way of speed. In fact, Bugatti built one of automotive history's most successful race cars, the Type 35. After Ettore and his son Jean died, the Bugatti brand went dormant in the early 1960s. But Volkswagen bought it in 1998, and Bugatti came roaring back to life with the Veyron, the fastest production car in existence. Built here at its ancestral headquarters in Mulhouse, France, it's the most powerful and expensive production car in the world. The cars are made here in a building referred to as the Atelier. The people at Bugatti think of Veyron as much more than just a car. To them, it's an automotive work of art. Each car begins life here in the design department. As futuristic as the Veyron may look, it still features the famous Bugatti horseshoe-shaped grille, developed by Ettore. Ettore's son, Jean, was a talented stylist. He created sweeping curves that came to define the Bugatti look, and those curves reappear on the Veyron. Lightweight and strong, carbon fiber is the ideal material for constructing a supercar like the Veyron. Here, a machine called the plotter cuts a sheet of carbon fiber into the required shapes. The material, which is stored at -4 degrees Fahrenheit to preserve its form, is heated to +64 degrees just prior to cutting. And Bugatti uses different kinds of fiber depending on what part of the car they're building. Where certain components require flexibility, others need rigidity. A worker positions the carbon fiber in a mold. To create a part, she must layer multiple sheets or plies of the fiber in a specified order. This layering process adds strength. To avoid creating any wrinkles, she carefully cuts and overlaps the material at the corners. Although she makes it look easy, this job requires an enormous amount of skill and experience. Each layer of fiber must be carefully positioned to ensure maximum performance. The pattern of the fibers must be perfectly aligned. The mold then comes here to these giant ovens, which are called autoclaves. Autoclaves apply a combination of heat and pressure to cure the carbon fiber. After 4 hours of baking at 275 degrees Fahrenheit, under 87 psi, the part is ready. Workers remove it from the mold. While almost all the work of creating a Veyron is accomplished by hand, sometimes a robot comes in handy. Here, a CNC machine trims off excess material and drills any necessary holes. Next, the parts come here, where skilled craftsmen prepare the surface. They begin by sanding with a heavy grit material. They repeat this time-consuming, painstaking process multiple times, with increasingly finer grits until the surface is perfectly smooth. This technician performs a highly detailed quality control check. She inspects every inch of the surface, marking any imperfections that need to be corrected. There's no time restraint. Each component must be absolutely flawless. Using precision calipers, she carefully measures the diameter of the holes to ensure they're the correct size. Once the components have passed inspection, workers mount them on a monocoque chassis. Like tailors putting together a suit, they make sure the parts fit together correctly. The weave pattern must align, and they even measure the gaps. Bugatti designers look for inspiration in everything, from pigments to chunks of crystal. Here, designers work on the blue-themed Veyron, deciding how best to match different tints to the interior and exterior components of the car. Their inspiration is the racing color that adorned many early Bugattis. Cars racing in the first half of the 20th century bore the racing color of their country of origin. The French racing color was blue, and blue has become a distinctive color for Bugatti. Like nearly every other step in the creation of a Veyron, the painting process is accomplished by hand. And once again, skill and experience are critical to doing the job right. Here, a painter applies layer upon layer of a clear coat. Often, customers request a clear finish that reveals the carbon fiber structure underneath. But customers can also choose any color they desire. It could even be the shade of red found on a favorite tie. To give the color depth, the painter may apply as many as 10 or more coats. One look at this colossal 16-cylinder engine and its 7-speed direct-shift gearbox transmission, and you begin to understand why the Bugatti Veyron holds the record for the fastest production car in the world. Veyron engines are hand-built. 2 experts build each one piece by piece from a combination of aluminum, titanium, steel, and magnesium. The process is so meticulous, it takes 2 weeks to build a single engine. Here, they install the crankshaft in its housing before bolting on temporary spacers to hold it in place. This will allow them to rotate the engine block in preparation for the next step. It's now time to install the pistons, which can only be inserted from above. The connecting rods are made of titanium, illustrating Bugatti's famous flair for detail. Ettore Bugatti's initials can even be found here, where they will be invisible once installed. The worker rotates the piston rings to prevent knocking and to effectively seal off the combustion chamber from the crankshaft. The worker then oils the piston by hand to prepare it for installation. A clamping device uniquely designed to hold pistons allows him to carefully situate the component before sinking it into position. Rotating the engine block, he removes the temporary extensions to prepare for the next step of attaching the rods to the crankshaft. This part is called the connecting rod cap. After applying grease, the technician bolts the cap onto the connecting rod, securing it around the crank pin. He then uses a hand tool to loosely fasten the bolts in place. Then, a custom-made device finishes up the job, simultaneously tightening the fasteners to the precise torque specified by the engineers. A monitoring system keeps track, ensuring that all bolts are correctly tightened. Now, the technicians carefully lower the bearing case onto the crankcase, sealing in the crankshaft. The finished 8-liter 16-cylinder engine will produce 1,200 horsepower at 6,400 RPM. And it will have a torque of 1,100 foot-pounds between 3,000 and 5,000 RPM. First, the technicians have to install the lower intake manifold. There are 2 upper sections of the intake manifold, each feeding 8 cylinders. Like the bulk of the engine, these components are aluminum. Look closely and you can see a tiny version of Ettore Bugatti's initials on the heads of the aluminum bolts that secure the manifold. The engine is now complete. It's time to transfer it to the testing facility and start it up. The engine spends 8 hours on the testing rig as technicians rev it up to its full power and torque in multiple cycles. While monitoring the performance, the technicians also run in the engine. There will be no need for customers to break it in slowly. The exhaust manifolds and turbochargers glow red hot, their surface temperatures reaching up to 1470 degrees Fahrenheit, with exhaust gases at 1800 degrees. The engine is now completely assembled, tested, and run in. A technician performs the final quality check and prepares it for transport. This quad-turbocharged 8-liter behemoth produces 1,200 horsepower. Unique among production engines, it has 64 valves, but thanks to careful engineering, it only needs 4 camshafts. At its top speed, the engine inhales 5,300 liters of air per minute, as much as you breathe over 5 days. Nearly every inch of a Bugatti Veyron interior is covered in leather. With hundreds of pieces of leather to prepare, it takes 12 to 15 cowhides to upholster a Veyron. And of course, it's all done by hand. Ettore Bugatti once said of his cars, "Nothing is too beautiful and nothing is too expensive." His son Jean agreed, believing tailor-made service should be one of Bugatti's highest priorities. Customers can choose from one of more than roughly 45 colors of leather. Bugatti sources these hides from cows raised high in the mountains of Austria. That environment is free of mosquitoes and barbed wire, so the cow hides are nearly flawless. But inevitably, there will be a few irregularities. This artisan spreads a hide on a specialized table, which uses a clamping device to stretch the leather tight, allowing for close inspection of the surface. A bright, even light helps the worker meticulously examine every inch of the hide. Wherever she finds even the tiniest flaw, she circles it with a special pencil. While the flaws may simply be naturally occurring wrinkles or dents, they must be marked and avoided. Steering clear of the marked flaws, the craftswoman lays a set of stencils on the leather. These represent the leather required to upholster a door. She carefully traces the outlines of each stencil on the hide. She then removes the stencils to clear off the leather and make room for her scissors. It's the same procedure a seamstress uses to make a dress, but in this case, it's a car door that's getting an outfit. Given Bugatti's emphasis on custom work, it's no surprise the artisan does her cutting by hand. Clipping divots at intervals along the edges will make it easier to align the leather properly. It's important that all the pieces be precisely the same thickness. This device shaves the underside of the leather to the same prescribed depth. In this case, nearly half the original thickness. To prevent bulkiness where the pieces overlap, an operator uses a purpose-built machine to shave the edges of the leather down even further. This process, known as skiving, is just one precision element of fine leather craftsmanship. Ettore Bugatti was known to have a great passion for leatherwork. The machine this artisan uses simultaneously stitches and trims the pieces as she works. Bugatti's attention to detail in upholstering the Veyron is a throwback to the early days of car manufacture, when specialized coach builders made custom interiors for each car. As she works, the interior of the car door begins to take shape. With a steady hand, a skilled craftswoman applies a decorative stitch using a pale blue thread on dark blue leather to create contrast. A popular customer choice, this stitching technique is called quilting. A finished example of this style of decorative stitching will cover an armrest that forms part of the center console. When it comes to leatherwork, the possibilities are nearly endless. Customers can even choose a woven pattern for their upholstery. A worker now begins the painstaking process of attaching the leather to its substructure. He begins by carefully and thoroughly wedging a section of seam into a slot. Next, he brushes a glue onto the substructure and carefully brings the leather over it. This glue is a polyurethane-based adhesive that remains flexible even after it cures. To work properly, the glue must be thermally activated. Here, the upholsterer uses a heat gun to do the job. A flat handheld device removes any air pockets that would compromise the adhesion and ensures that the leather hugs the substructure tightly. The door panel has been fully upholstered and trimmed. But will it fit? To ensure that all the dimensions are correct, a worker attaches the panel to a mock-up door. A quality control inspector then verifies that all levers and knobs are in perfect working order. She also uses a spacer to examine the divide between the upholstery components. These gaps must be uniformly the same width. Bugatti makes just 40 Veyrons per year on average. And like other works of art, this supercar is a limited edition. Only 450 of them will ever be made. Bugatti calls its 1,100 square foot production facility the Atelier. Instead of a typical assembly line found in most car factories, the Veyron is assembled at individual stations. Here, a technician unites the transmission with the engine and carefully bolts them together with the handheld ratchet. The mechanical components of the car's rear section have all been assembled. Technicians push the back end along a track to meet the front. The track sits below the floor and is covered by metal plates that open and close around the trolley feet as they move. The workers join the two sections with just 14 titanium bolts. Once again, they use handheld ratchets rather than power tools. The powerful mechanics of the Veyron have been assembled, but a Bugatti is not a Bugatti without its sculpted exterior. To bring the Veyron to its artful conclusion, technicians wear white gloves so as not to mar the surface with fingerprints. They install each component with the same care and precision used throughout. But before reaching this stage, an expert tests the car's systems at this rolling test station. These components are part of the rear wing assembly. At high speeds, the rear wing extends and provides massive downward force to keep the car firmly on the ground. And when the driver brakes, it immediately flips to a vertical position, adding the braking power of the hatchback to the car's powerful ceramic discs. Here, a specialist prepares the car for its final inspection. The car will spend 2 entire days at this station as he painstakingly buffs and polishes the car to shining perfection. He must ensure that every inch of the surface is absolutely flawless. If there are any imperfections, this man will find them. It's his job to give each Veyron its final inspection. No Bugatti leaves this facility without his approval. Surrounded by full-spectrum lights, the car undergoes a meticulous examination. If the inspector discovers any flaws, he will send the car back to the previous station for more polishing. Before a Veyron goes through final inspection and sign-off, an engineer takes the car out to a test track. and drives at 185 miles for a final dynamic approval test. The Bugatti Veyron has set 2 world records, one for the fastest production road car and one for the fastest convertible with the roof down. This orange and black Bugatti Veyron 16.4 Grand Sport Vitesse is the car that set that second record by going 253 miles per hour with its top down. And true to the Bugatti legacy, it looked good doing it. You need to go 93 miles an hour just to get this car out of second gear. It accelerates from 0 to 60 miles per hour in 2.6 seconds, from 0 to 120 in 7.1, and from 0 to 180 in 16 flat. It's no wonder the Veyron has achieved iconic status among supercars at warp speed. Today on How It's Made Dream Cars, the Chevrolet Corvette Stingray, a legend reinvented. In 1981, General Motors moved its Chevrolet Corvette assembly plant to Bowling Green, Kentucky, which is also home to the National Corvette Museum. Here, a bust pays tribute to Zora Arkus Duntov, the man known as the father of the Corvette. The first Corvette design was led by General Motors head of design Harley Earl in 1953. Not long after, Zora Arkus Duntov saw that original car at a New York Motorama exhibition and fell in love with the Corvette look. By the 1960s, he helped create the famous Corvette Stingray, a stylish and powerful sports car. Chevrolet stopped using the Stingray name on Corvettes after 1976. But with the 7th generation of the Corvette, the Stingray rides again. It incorporates aluminum and carbon fiber materials, together with state-of-the-art powertrain technology. This car has been completely redesigned to create a fast, lightweight update to the automotive legend. Here, a robot positions components of the Stingray frame in a jig, known as a geometry setting tool. With the first component in place, a worker loads in a part called the seat back beam, followed by the seat back panels and the tunnel side panels. These are all part of a component simply called the tunnel. Once the setting tool has clamped everything firmly in place, the wall behind it pivots on its axis and swivels 180 degrees, revealing a recently welded tunnel. On the other side of that wall, a pair of robots begin welding the parts. Just 155 seconds later, the tunnel is welded and ready for the next step. A robot prepares the body length rails. A second robot loads the tunnel between the rails on the tooling fixture. The car body begins to take shape as the front and rear bumpers go on. All of the components are made of aluminum, which offers rust-free rigidity, lightness, and durability. Once all the components of the frame are clamped in place, a robot quickly welds the joints before the frame heads to the next station. By the time the Stingray is finished, it'll have roughly 350 resistant spot welds and about 70 laser welds. That's more than 36 feet of laser welds. While the frame is a vital element of the Corvette, the body panels create the Stingray's distinctive look. Here, a worker loads a set of panels onto a carrier. The carrier moves at a speed programmed to keep up with the pace of production. At the priming booth entrance, a reader scans the unique barcode located on each carrier and sends the information to a computer, which tells the robots what to do. In just 2.5 minutes, they prime the entire set of panels. The panels then head across the hall into a giant oven where they will bake for 30 minutes at a temperature of 260 degrees Fahrenheit. After that, the panels will receive a base coat in one of 10 different colors, followed by a clear coat. Finally, they arrive here, where a team of technicians inspect the surfaces and correct any defects with sanders and polishers. The paint shop also handles another process called sonic welding. Here, a worker positions the Corvette emblem in a fixture, then lays the car's fascia on top. He inserts composite brackets into the fascia. The fascia and the brackets, which are made of a material called thermoplastic polyolefin, or TPO, form the nose of the car. These brackets will provide locating points for the headlight installation. Once they're installed, the worker clamps them in place. A robotic arm begins the ultrasonic welding process. This means it uses high-frequency sound waves to melt the bracket onto the fascia at specified weld points. These sound waves are inaudible. There are 25 weld points for this part. The robot completes its task in just 3 minutes, perfectly bonding the brackets and the emblem to the panel. At the heart of every Corvette is a classic American V8 powerhouse. The Stingray's engine is 6.2 liters, 461 horsepower, and has a top speed of 190 miles per hour. The engines are made here at the GM Tonawanda Engine Plant in Buffalo, New York. They start with a precision sand-cast aluminum block. Here, a team of robots conducts a series of tests, including the water jacket leak test and blockage tests. A camera checks for the presence of all the necessary threaded holes that will provide attachment points during the assembly of the car at Bowling Green. A data bolt, which is an actual bolt that contains a computer chip, records the engine's progress as it moves through production at Tonawanda. Here, a worker prepares to install the crankshaft. He places a specialized guide in the block to prevent any damage to the crankcase as he lowers the pre-oiled crankshaft into position. These powdered metal piston rods are known as fractured rods. That's because the supplier actually breaks them at the point where they will encircle the crankshaft. The irregularity of the fracture surfaces allow the technicians at Tonawanda to realign the rods perfectly during installation. Now, a technician uses a device called a piston cup to compress the piston rings at a tapering angle. This makes it easier to slide the piston assembly into the cylinder. The second worker uses a blue tool called a guide fork to guide the rod in without damaging the piston liner or the crankshaft. This is the oil pan RTV station. RTV stands for room temperature vulcanization. With the bottom section of the oil pan clamped upside down, the machine squeezes a thin bead of RTV around its perimeter. A camera verifies that the orientation is correct. The machine flips the bottom section of the oil pan 180 degrees and brings the top section up to meet it. The turntable then swivels, delivering the next oil pan while allowing the worker to transfer the finished one onto an inverted engine block. This process must be accomplished quickly before the RTV has a chance to cure. 16 spindles descend to tighten the oil pan fasteners to the precise torque required. Here at the head sub-assembly station, this machine installs both exhaust and intake valves at the rate of 48 parts in just 40 seconds. One of the arms grabs a set of valve components, dips them in oil, and inserts them. The machine flips the head, then the second arm installs a series of springs, compressing them slightly and dropping a key down inside them. As the spring decompresses, the key locks, holding the spring in place. A technician positions a component called a cylinder head gasket on the engine before installing the head. This gasket is a high-tech multi-layer steel component that must seal in oil, coolant, and combustion. The cylinder heads integrate a fuel rail to accommodate the direct injection fuel system. Two workers insert the 16 push rods that will transmit motion from the camshaft to the valves. Once the rods are in place, the workers install components called rocker arms. The motion of the camshaft will transfer through the push rods to the rocker arms and then to the valves. The workers have only partially screwed the rocker arms in place. At this station, a specialized device orients the engine so that no valves are open before tightening the bolts to the necessary torque. This operation is called the rocker arm rundown. A technician installs the rocker cover and coil packs. The rocker cover seals the valve train, while the coil packs supply ignition energy to the spark plugs. A piece of foam sound insulation goes over the engine before a technician positions the high-density composite plastic intake manifold on top. Last but not least, a machine attaches the exhaust manifold together with its gasket. Made of cast stainless steel for strength and durability, the exhaust manifold features equal-length runners for optimal engine performance. From start to finish, the new Chevrolet Corvette Stingray will travel 7 miles on a network of conveyor systems as workers transform the components into a complete car over the course of 3.5 days. Since 1981, all Corvettes have been made here in Bowling Green, Kentucky at the Bowling Green Assembly Plant, which covers 1 million square feet. To build the car, workers rely on a special conveyor system known as a tow-veyor. This consists of tow carts which move at precisely timed speeds along tracks set in the floor. This allows workers to mount components on the chassis as it moves, ensuring smooth, timely assembly. Here, a worker uses a hoist to settle the transmission into its cradle, where they will secure it. The new Stingray comes with 2 transmission options, an 8-speed automatic transmission with paddle shifting, or a 7-speed manual transmission with active rev match. As the chassis moves along, the engine travels a parallel assembly line. The 2 lines meet at precisely the right time. Workers transfer the finished engine to the chassis and lower it into position. Workers now connect a long cylinder called a torque tube, which will transfer the engine's torque to the transmission. And of course, the transmission will be controlled from the Stingray's high-tech cockpit, which is ready for installation. All the joints get a protective coating of urethane before a robot lowers the cockpit onto the car frame. 32 bolts on each side secure it in position. At this station, a robot applies a urethane adhesive on a component called the wheelhouse, as a cart docks a car in a precise location. Automated lifts install the wheelhouses on the car and hold them there for 90 seconds as the adhesive cures. A worker brings the left rear quarter panel to the car and attaches it with several screws on the top and several in the door frame. Next, she installs the fuel nozzle. With the new Corvette Stingray, you'll never accidentally leave your gas cap behind at the service station. That's because there is no gas cap. Thanks to a clever spring-loaded mechanism, the nozzle self-seals when you finish fueling up. Next, technicians use hoists to install the seats. There are two different seat options, the standard GT and the competition Sport. A protective ring around the perimeter of the door opening ensures this process won't damage the car body. A worker removes the backing from a self-adhesive Corvette emblem. He uses a jig to make sure the emblem is perfectly positioned before adhering it to the rear fascia of the car. While there, he also takes the opportunity to test the rear LED lights. He now rotates the panel to the upright position. Although the rear fascia is lightweight, Corvette mandates that two workers should walk the part to the car. This helps prevent damage being done to either the part or the car, as the workers carefully install it together. The powertrain and the car body have been assembled on two separate conveyor lines that are precisely timed to converge here. The overhead conveyor slowly lowers the body, as the tow-veyor raises the powertrain to meet it. Once technicians have bolted the body and its powertrain together, workers install the hood, which is made of strong, lightweight carbon fiber. A technician then uses spacers or gap tools to make sure the gap between the hood and the rest of the car body is the correct width. After fastening the hood to the car at its attachment points, he double-checks the width with a set of gauges. Satisfied, he removes the gap tools. A worker now installs the headlights. The Corvette Stingray features amber LED turn signals, framing the bi-xenon frosted indirect HID high and low beam headlights. There are also white LED DRL under each projector. With the lights fully installed, two workers can now carry the front fender to the car and position it for installation. The fender includes the Stingray's distinctive grille and the Corvette's famous emblem. A technician uses a hoist to position the wheels for installation. The wheels feature Michelin Pilot Super Sport tires, specifically designed for the Stingray. A fully decked out 7th generation Corvette Stingray features magnetic selective ride control, head-up display, a 10-speaker audio system, and a drive remote selector with 5 different options. These Corvettes are completely assembled. An overhead conveyor system slowly lowers them until the wheels touch the ground for the first time. The car has a dry weight of 3,159 pounds. With all its fluids, the curb weight will be 3,302 pounds. Here, bright side lighting allows technicians to carefully inspect the car for any flaws in the paint job or the gaps between the body panels. A worker then starts the car up for the first time and drives it over a rumple strip to an alignment station. Here, technicians will use precision equipment to perfectly align the steering system and the headlights. In a pit under the alignment station, a worker carefully adjusts the wheels. The steering wheel must be no more than 5 millimeters off its center position when the wheels are pointed straight ahead. Simultaneously, an optical sensor moves back and forth in front of the car to gauge the position of the headlights. At a distance of 25 feet, the middle of the headlight beam can be no more than 5 millimeters off center. The car is now ready for the dynamic vehicle test. Here, a driver tries out every switch while revving the car up to 80 miles per hour. as a computer runs over 800 tests in just 2 minutes. It checks everything from the engine cylinders to transmission shifting and emission levels. Once past the dynamic vehicle test, the car must endure a powerful simulated tropical storm. This is known as the water test. For 2 solid minutes, high-pressure jets hammer the car with 12 gallons per second. The driver uses a flashlight to examine the interior for any signs of leakage. Under such an intense barrage, the smallest crack will show up. The driver now takes the car over something called the squeak and rattle track, which simulates different road conditions. As he drives, he listens carefully for what else? Squeaks and rattles. The new Stingray is the latest in a long line of famous Corvettes. In fact, Chevrolet has made more than 1.5 million of them in total. In production since 1953, the Corvette is the world's longest-running, continuously produced passenger car. The original 1960 Stingray took more than just its name from that hydrodynamic fish. The design of both the old and the new Corvette Stingray features smoothly curving transitions from surface to surface, enabling air to flow over and around it at high speed. This design feature, taken together with the new Stingray's powerful V8 engine, high-tech transmission, and lightweight construction, make it a true Corvette, paying tribute to a celebrated past while roaring into the future.